Hi, in this video, we're going to take a look at finding values of trigonometric functions using the unit circle. Well, the unit circle is a really cool thing in terms of working with these angle measurements and the trigonometric ratios and functions, because it turns out that the points on the unit circle can be used to find what those trigonometric functions are. And here's how it goes. The sine of theta, remember, we use theta often to talk about our angle measurements, is just equal to y, and that's a y coordinate on that point there. The cosine of theta is just equal to x, and the tangent of theta is equal to y over x. Okay, so we can use those along with the points that are on there to find the trigonometric ratios and the trigonometric functions for lots of these common angles, which can be really handy. So let's start with this first one, the sine of 16 degrees. Okay, so let's find 16 degrees right here. Here it is, and there's my point 1/2. And the square root of 3 over 2. The sine is just the y coordinate, so I'm just gonna pick out that y coordinate, and that's gonna be my sine. So the sine of 16 degrees is equal to the square root of 3 over 2. The really nice thing about this is it allows us to get an exact value for that sine. If we just put that into our calculator, we will get a decimal approximation, but this gives us an exact value. And remember, it's always good to be more accurate, and this exact can't get any more accurate than that. Okay, cosine of 5 pi over 3, well, let's find 5 pi over 3, and there it is, 300 degrees. Okay, the cosine is the x coordinate, so remember, xy, there is our x 1/2, so 225, the it is, and the tangent is y over x. So y over x, well, looks like we have the square root, are the negative square root of 2, and that's gonna be over the negative square root of 2 over 2. Oh, we are dividing the same thing by itself. So remember, when we do something like that, even so those are kind of crazy looking. It's just equal to 1, however. Okay, here we are 115 degrees. There's my point. Remember, cosine is the x coordinate, so there is the cosine of 115 degrees is equal to this negative square root of 3 over 2. Alright, let's do one more. How about the tangent? Let's do 2 pi over 3. 2 pi over 3, I want that tangent. Well, what I need to do again, first of all, find, and there is our 2 pi over 3, and the tangent, remember, is y over x. So okay, here we go. It's gonna be equal to the y coordinate. There is the square root of 3 over 2, and then it's divided by negative 1/2. Now this, when we get to fractions stacked on top of each other, sometimes it looks a little scary, but remember, what this really means is the square root of 3 over 2 divided by negative 1/2. And we know how to divide fractions. We just go ahead and keep change and flip. So we keep the first, the square root of 3 over 2, change the division to multiplication, flip the second one, then I can cancel out this 2's here. Getting kind of small, but hopefully You can still see that, and I'm left with the square root of 3 on top times 1, so that will just be the square root of 3. And on the bottom we have 1 times negative 1. So what would be negative 1? I can pull that up on top, so we just have the negative square root of 3 is the negative 1. And no, it's not 1. We have the negative square root of 3 is the tangent of 2 pi over 3. Okay, so finding trigonometric that our values of trigonometric function using the unit circle. Right here, these things come in very handy for us. We can use this to just pull those values for those trigonometric functions right out of those points which are on our unit circle. You should be familiar with the graph y equal sine x, y equal cosine x, and y equal tangent x. In this lesson, we will find the domain and the range of the basic trigonometric functions. We call that the domain of a function is a set of possible input values, and the range is a set of possible output values. That is, the domain is a set of possible x values, and the range is a set of possible y values. In terms of the graph, the domain is a portion of the x-axis that is covered or shadowed by the graph, and the range is a portion of the y-axis that is covered or shadowed by the graph. The inputs to the functions sine and cosine are typically thought of as angles on the unit circle, measured in either degrees or radians. Every angle has a sine value and a cosine value. So the domain of both the sine function and the cosine function is everything from minus infinity to infinity. The range of the sine function is all possible output values. The sine values are found by finding the vertical distance on the unit circle corresponding to an angle. The unit circle has its highest value at 1, which occurs at 19 degrees, and its lowest value at negative 1, which occurs at negative 19 degrees. The range of the sine function is therefore all numbers between negative 1 and 1. The same applies to the cosine function. The output of the cosine function is the horizontal distance on the unit circle. The largest value occurs at the rightmost point of 1, which corresponds to the input angle 0, and the smallest value occurs at the leftmost point of negative 1, which corresponds to the angle 118 degrees or pi radians. Therefore, the range of the cosine function is also all numbers between minus 1 and 1. The tangent function likewise is defined for all angles, except that the denominator cannot be 0. The denominator of the tangent function is 0 when the point on the unit circle is at the top or the bottom. That is at pi over 2 or 3 pi over 2. Or the corresponding angles found by going full circles from those two angles. Tangent values can be arbitrarily large if the angle is slightly less than 19 degrees. The sine value is 0.99 something, and the cosine value is 0.00 something, yielding a very large tangent value. The range of the tangent function is all real numbers. For the inverse functions, the inputs and outputs are reversed. The inputs of an inverse trigonometric function are numbers, and the outputs are reversed. The inputs of an inverse trigonometric function are numbers, and the outputs are angles. And what are the possible inputs for inverse sine and inverse cosine? They are the possible outputs of sine and cosine, namely all numbers between negative 1 and 1. It is tempting to think the range of the inverse sine function is the domain of the sine function for the same reason. but there is a problem. There is more than an angle that has the sine value of 1. We need to decide between pi, 5 pi, and all the other angles whose sine is 1. For example, the inverse sine function, we pick the angles on the right half of the circle, namely the angles between the minus pi and the pi. For the inverse cosine function, we pick the angles on the top half of the unit circle, the angles from 0 to pi. Since the range of the tangent function is all real numbers, the domain of the inverse tangent is all real numbers. Similar to the sine functions, the tangent functions runs through its complete list of possible values on the right side of the unit circle. So the range of the inverse tangent function is all angles between minus pi and pi. Note that the tangent is undefined at minus pi and pi, so the range does not include those values. The domain and the range can also be found by analyzing the graph of a function. The graph of sine and cosine go forever to the left and to the right. So the domains of each are all reals. The waves oscillate between -1 and 1, shown here bounded by the green lines, which bound the range between -1 and 1. The tangent graph goes infinitely far below and above the y-axis, so the range is all real numbers. The inverse sine graph looks like this. It begins at the bottom left at the point -1, -pi. It can't go below minus pi, since if it did, it would start bending back to the right, causing the graph to fail the vertical line test. It likewise ends at the point 1 and pi. The domain goes from -1 to 1, and the range from minus pi and pi. Similarly, the domain of the inverse cosine function goes from -1 to 1, and the range from 0 to pi. And the domain of the inverse tangent function is all real numbers, and the range is from minus pi to 2 pi. Here are the domains and the ranges of the basic trigonometric function. In our calculation, minus and minus, the meaning is lost. Likewise, if you have a lot of bad qualities, a person can sink into the bottom. Therefore, do not stop imbibing good qualities in yourself. I hope that this video will helpful for you guys. Keep working hard on your math, and I know you will do fantastic.